Spice Math. That's right. We add it up, multiply it, man. Spice Math. Oh yeah. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello everyone, and welcome back to another episode of Spice Math. In this lesson, we are going to be solving the linear inequation, part 1. This lesson is catered for forms 3 to 5. Let's take a look at our objectives. Here are our objectives. 1. Define a linear inequation. 2. Identify the different forms of linear inequations. 3. Identify the features of a linear inequation. 4. Solve linear inequations by adding the same quantity to both sides. And 5. Solve linear inequations by subtracting the same quantity from both sides. A linear inequation with one unknown is an inequation which can be written in the form ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, and ax plus b is greater than or equal to 0, where a and b are constants or fixed real numbers, and x is the unknown value. We can think of an inequation as an unbalanced seesaw, since one side is not equal to the other side. And here we have a cute illustration of that. Features of a linear inequation. 1. There is one unknown. 2. Its solution is a range of values that is given as a solution set, and we're going to get to this shortly. 3. The solution set can be represented on a graph. And 4. The inequality must remain true. We can solve linear inequations by adding the same quantity to both sides. Let's look at this example. We have x minus 3 is greater than 4. Remember, with the greater than symbol, the open end points to the larger side, whereas the closed end points to the smaller side. So we have x minus 3 is greater than 4. By adding 3 to both sides, we get x minus 3 plus 3 is greater than 4 plus 3. When we simplify this, we get x is greater than 7. Hence, the solution set is x is such that x is greater than 7. So this is how we represent our answer. X is such that x is greater than 7. We can also solve linear inequations by subtracting the same quantity from both sides. For example, we have x plus 2 is greater than or equal to 7. By subtracting 2 from both sides, we get x plus 2 minus 2 is greater than or equal to 7 minus 2. When we simplify this, we get x is greater than or equal to 5. Hence, the solution set is x is such that x is greater than or equal to 5. Now, we're going to head to the board and try these few questions. So let's take a look at our first inequation. We have x minus 5 is less than or equal to 8. We are going to solve this linear inequation by adding 5 to both sides. When we do so, we get x minus 5 plus 5 is less than or equal to x plus 5. When we simplify this, we get x is less than or equal to 13. However, that's not how we represent our answer for this linear inequation. We have the set x is such that x is less than or equal to 13. Let's represent this in symbol. So we have the set x is such that, and that's represented by a colon, x is less than or equal to 13. This is how we would represent our answer, and let me explain this. This means that x can be any one of these values: 13, 12, 11, and so on and so forth to negative infinity. Let's look at our second linear inequation. We have y minus 4 is less than 3. We are going to solve this inequation by adding 4 to both sides. When we do so, we get y minus 4 plus 4 is less than 3 plus 4. We simplify this to get y is less than 7. Now, we know that we cannot represent our answer like this. Our answer must be represented as a solution set. So, in words, we have the set y is such that y is less than 7. Let's write this in symbols. The set y is such that, and such that, remember, is represented with a colon. So the set y is such that y is less than 7. Assuming that y is an integer, the set y can be these values. Y can be 6, 5, 4, 3, and it can continue to negative infinity. Here we have x plus 9 is greater than or equal to 12. We're going to solve this linear inequation by subtracting 9 from both sides. When we do so, we get x plus 9 minus 9 is greater than or equal to 12 minus 9. This simplified would give us x is greater than or equal to 3. Now remember, again, we cannot represent our answer as x is greater than or equal to 3. Our answer must be represented as a solution set. So in words, we have the solution set, and it reads, the set x is such that x is greater than or equal to 3. My bad. I'll just add that in. And I'll read that again. The set x is such that x is greater than or equal to 3. And this written in symbols would be the set x is such that x is greater than or equal to 3. Now, assuming once again that x is an integer, the values of x can be 3, 4, 5, and continues to infinity. Okay, so for this linear inequation, we have y plus 6 is greater than 13. And we're going to solve this by subtracting 6 from both sides. When we do so, we get y plus 6 minus 6 is greater than 13 minus 6. When we simplify this, we get y is greater than 7. So once again, we have to represent our answer as a solution set. So we have the set y is such that y is greater than 7. And this in symbols would be the set y is such that y is greater than 7. Assuming that y is an integer, y can be any one of the following values. Y can be 6, my bad. Y can be 8, 9, 10, and it continues on to infinity because y is greater than 7. Okay, so for our last linear inequation, we have 7 is less than x plus 3. Now this looks a little bit different. Why? Because we have our unknown value on the right-hand side of this inequation. And we think it's customary to have the unknown value on the left-hand side of the inequation. So I want to show you something. This inequation can also be written in this form. Now pay close attention. We can have x plus 3 is greater than 7. Now, if you recall the features of the linear inequation, one of those features is that the inequality must remain true. So if we have here that 7 is less than x plus 3, then 7 must remain less than x plus 3. And that simply means or translates itself to x plus 3 being greater than 7. So we can now go ahead with this inequation. We are going to solve by subtracting 3 from both sides of the inequation. So we have x plus 3 minus 3 is greater than 7 minus 3. We're going to simplify this, and we will get x is greater than 4. But of course, we cannot leave our answer like this. We must represent it as a solution set. So we're going to go straight ahead and do that. So the set x is such that x is greater than 4. And once again, assuming that x is an integer, x can be any one of the following values. X can be 5, 6, 7, continuing on to infinity. Here's an assessment for you to do. They are all yours. Solve the following. Thank you once again for joining us on this episode of Spice Math. I hope you keep on practicing because that's the only way you will get better at math.
You won't believe it's just math. You won't believe it's just math, Spice Math, that's right. You add it up, multiply, man, Spice Math. Okay. A couple things we're gonna learn today, Spice Math. All right. Take some time, educate yourself, Spice Math. That's right. You won't believe it's just math. Come on. It's just math.